In this video, we're going to show an example of integrating a base A exponential function in a very simple case where we don't need a chain rule or any other specialized techniques. So here it says integrate the function pi times 2 to the x. So we have a base 2 exponential function inside the integral. We want to recognize that pi is just a constant, which means pi can be factored out of the integral. So we're just doing pi times the integral of 2 to the x dx. And as we saw in the previous video, when we're integrating a base A exponential function, we just get a to the x over the natural log of the base plus that constant of integration. So continuing, we get pi times the antiderivative of 2 to the x is just going to be 2 to the x over the natural log of the base, which in this case is 2, and then it needs to be plus a constant of integration. So there's the antiderivative in question. If you needed to check your work, then we would take the derivative of this and try to make sure that we get back the original function, which was pi times 2 to the x. So if we take pi times 2 to the x over the natural log of 2 plus c, if we take d dx of this, we get d dx of a constant is just 0. And here I have the derivative of pi over the natural log of 2, which is just a constant. So we have pi over the natural log of 2, a constant. So when we take the derivative of a constant times a function, then we get the constant times the derivative of that function. So the constant times d dx of 2 to the x. And as we saw in previous videos, the derivative of 2 to the x is just the natural log of 2 times 2 to the x, and the plus 0 we can drop. And here we get the natural log of 2 divided by the natural log of 2 is 1, so we get pi times 1 is pi times 2 to the x, which is indeed the function that we started with when we were integrating.